Hello, mathematicians. We are on episode 5, second last episode for 6 for a band 6. Today we're looking at rates, and I've literally dedicated this entire video to just look at rates because they're pretty tough a lot of the time. It involves a bit of a problem solving skill, which can involve some mentally challenging questions. So it comes up a fair bit as well. Okay, so let's have a look at our rates. I've broken it down into 3 main areas. Okay, so we've got looking at just scale questions, then capture, recapture, and similar triangles. But what you're actually going to find is these 3 different things all test the same skill, okay? It's being able to apply a rates question, okay? They're just 3 different applications of it. So let's start with scale. So what's going to happen is they're going to give you a diagram, say, and you will need to use your ruler. So please make sure you take a ruler into your exam. And you usually will form the scale based off what they might give you. Okay, so they might give you a swimming pool and say that it's 100 meters long, and then you might measure it and it's 10 centimeters. Okay, so then out of that you form your scale. Now, we call a scale factor. It's basically writing the ratio as a fraction instead. Okay. And there's this formula here for it. I'm going to show you how we can apply and use this formula with this question here. Now this question may be familiar to a lot of you because we have looked at one nearly the exact same, I think, or if not, it was the exact same. So let's have a look. They've given us a really ugly scale, okay? Most of the time the scale is nice, like 1 to 100, okay? But at least if I show you how to do it with a really hard scale, doing it with an easier scale, if they do ask you for an easier scale, will be easier for you. So let's have a look. So that means 2 to 87. So whatever it is, whether it's centimeters, millimeters, kilometers, every 2 on the page is 87 in real life, okay? Part 1 says calculate the drawing length in centimeters if it is actually 6 kilometers. So pause the video here if you like and give it a go. Otherwise, I will talk through it now. So we're going to use this formula in green here. It says that the scale factor is equal to the length of the drawing over the real length. Okay, so our scale factor is what they've given us here, 2 to 87. Now remember, as a ratio, it's the same thing as writing as a fraction. So here's my scale factor, and that's equal to the length on the page, which is what I need to find. They want to know what is the drawing length, and they've given me 6 kilometers. Now notice how I've written kilometers here, okay? Because I need to remember this is going to give me an answer in terms of kilometers, and I know they want centimeters. Okay, so you can either change it to centimeters here or just keep the kilometers, solve it, and then change your answer. So now all it is a equations question. I need to solve that for x. We know how to do that. We need to get x on its own. So we're just going to have to get rid of the 6 kilometers. It's dividing, so I take it over the other side, and I'm keeping the kilometers there always. Okay. Now, when I get my answer, it's just going to tell me that 0.1379, and I'm not finished with it, so I'm writing the whole calculator screen out, kilometers. They don't want it in kilometers though, they want it in centimeters, okay? So let's think about this, and I'll break it down. So we got kilometers, so I times it by 1,000 first to get it into meters. So that's 3 jumps. So I'm going to be left with 137.93103 meters, and then I times it by 100, so that's 2 jumps to get to centimeters. So I get 13793.103 centimeters. So that's how many centimeters it would be. Okay. All right. Part 2 now does it the exact same thing, but another way around. Fill it into your formula. Always go back to that formula. Calculate the real measurement. So I know my scale is still this. This time, it gives me that it's 172.34 millimeters on the page, and I need to find what it is in real life. Okay? This time, I just have to solve this equation. So thinking about how you might solve this equation, I would think of it as, okay, the only option I have is to take that x to the other side, okay? It's the one that needs to be by itself, but I can't get rid of the numerator from it, okay? You can only get rid of a denominator in a fraction like this. It's dividing, so I take it over this side and I times it. Millimeters, keep writing it. Now, remember, the goal is to get x by itself, so I have to get rid of my 187 that's timesing, so I take that over, and it's going to be ugly, but just be careful how you put in your calculator. Okay, so it was timesing, take it over and divide. And when you do that, again, remember this answer is going to be in millimeters. Okay, so they want to know what it's going to be in meters. So that's just a simple process. Now, please, in your HSC, just do it one step at a time. So if it's that many millimeters, I know it's going to be divide by 10, this many centimeters. And if it's that many centimeters, divide now by 100. And still, over all the years I've been doing all of these maths, I will always break it down. Because why would you want to rush that and get the whole question wrong just because you've rushed that last part of your conversion? Okay, so all it is going back to that green formula, the scale factor formula. So remember that. So what I'd like you to do now is pause the video and have a go at this HSC question. So for part 1, this is what I got. If you got that, well done. So let's just quickly recap what we did. Started with our formula, filled into the formula, x was on the bottom, so then it was just how I rearranged. I got my answer in centimeters, so I then turned it to meters, to then turn it to kilometers, okay? All right, part 2. There's our answer. So again, filling it in, this time x is on the top, rearranging, get your answer in kilometers, then go to meters, then go to centimeters. And these questions are actually, sorry, that's just my bird flying around. As I was saying, these questions are actually considered pretty tough questions in HSC, okay? Rates are always tough, but if you just follow these simple steps of that formula, you need to remember that formula, you're not going to be given it, turns the questions really straightforward, I believe. All right, capture, recapture. Okay, so first thing to do, it's going to be very similar skills of what we just did, okay? If you are confident, you can pause the video here and then see how you go. Otherwise, let's have a look. This is how I always do my capture, recapture questions. Hannah wants to estimate the number of eels in a lake. She catches and rings 50 eels. She returns the 50 eels. The next day she comes back, catches 400 eels and 10 are ringed. So when she comes back, 10 out of the 400 are ringed or tagged, whatever it is. What we need to know is that ratio is going to be the same ratio as what she first tagged. So when she first came, she caught 50 and tagged them out of the entire population, okay? As a side note, another way of thinking about it, let's think that this 10 over 400, it simplifies to 1 over 40, which if I turn that into a percent, just out of curiosity, it's about 2.5%. So that means that this 50 here is representing 2.5% of the total population. Okay, so it's just another way to think about it. But it's just about the ratios of them, okay? So they're all in the same ratios. The final way, and I don't like really relying on this way, but I will show you something as well. this is another way of looking at it. And again, I don't like this because the list of all the things you need to remember for your HSC, and this is just adding another one. Okay, so you can remember this little part. If you have a good memory, go for it. But it'll always be in this form. So it's always the second time on the left, and then first time on the right, and population on the bottom, okay? So if you stick with that little formula, it'll work every time. But again, it's just something else you're going to have to remember. So all it becomes now is just like above, rearranging a scale factor question. And there we have it, okay? So what I'd like you to do, this one's not exactly the same. It's a little bit tougher. Pause the video and give this a go. Fill it into your scale factor or your formula, write it how you need to, and then rearrange for what you need. So when you fill this one in, this time they've given you what her estimation for the total population is. But they didn't give you how many she originally tagged. So that's where, when you fill it in the formula, it's no harder, but you just got to fill it in the right spots. And in fact, this one's just a bit nicer to rearrange to get your answer. Okay? So remember, this answer is now how many she originally tagged. So they can ask all these recapture questions in any different way of rearranging. And you would find she tagged 80 originally. So then you could use 80 and do the question like we did on the last one and see if you get 125. So if you have the time in your exam, check it. The next thing is similar triangles. And again, you don't spend a lot of time looking at each one of these three techniques. They're just applications of rates questions, which you look at a lot of rates questions. What I want to remind you, and we talked about this a while ago, two triangles are said to be similar if one of two things happen. All the angles are equal, or the sides are in ratio. So as soon as well, in fact, both of those occur for a similar triangle, but as soon as you can pick one of them, then you can prove it. The only one to be careful of is part one there, all angles are equal. That can also be a congruent triangle, which we don't really look at, but just be mindful. A congruent triangles are two triangles that are the exact same. So two triangles next to each other, the exact same size of sides and angles, they're called congruent, okay, because they're the exact same as each other, okay. So if they're not the exact same size, but they all have the same angles, it's a similar triangle situation. So what I mean by that is, so let's say this one's 30, this would also be 30, even though it's smaller. And then if this is 60, this would also be 60, which would make that 90 and that 90. So they can have two different triangles that are different angles, the same angles, but different sides. Now, sides in ratio, notice the word ratio. What are we looking at? Rates. So if sides are in ratio, it means that, say, this first triangle is 2 times the size of the first triangle. So if this was 10 centimeters, this one would be 5. And if this was 8 centimeters, they could say, what's X? And you say, well, it's 4. Okay. So we could write it as a scale factor or a ratio, 10 to 5. So that side to that side, which is the same as 2 to 1. So for every 2 centimeters on the big triangle, it's 1 centimeter on the small triangle. So let's just quickly look at a HSC style of question, okay? Find the value of X in the following triangles. Now, notice straight away they've showed us by these symbols that this angle here is the same as this angle here by that, and then the dot means those two angles are the same, and then of course the right angle, they're the same. So what you can assume is they're similar triangles because they have equal angles. So let's have a look. We've got the scale factor. We've got, if this side here is 8 and this side's 4, clearly you can see it's just dividing by 2. If I needed to write the scale factor, I would say either as a ratio or I could write it as a fraction. Doesn't matter which one. Remember to simplify, so this would be 1 to 2 and then this would be 1 or 2. So if they ask you what the scale factor is of the triangles, you could write it like that. But this one here is just saying, well, find x for us. And it's really straightforward. So all they're doing is to get from the small one to the big one, they are timesing by 2, or if you want to think of it as from the big one to the small one, they're dividing by 2. So that just means x will be 10 centimeters. Okay. And the last thing I'll just point out is questions on this can give you something, and it's mean, but they can give you something like this. And I've seen it in a HSC. There's 2 triangles in this picture, okay? A lot of people will straight away see a triangle and a trapezium, but no, there's 2 triangles. There's your little triangle here that's super obvious, but then there's also the overall big triangle, okay? We call these triangles, those 2 triangles, so we've got triangle, and I always write them separately, A, E, B, and we've got triangle, that's bigger, DCA. Hopefully you can see that. They are similar triangles because, well, they're both a right angle. They both share that common angle at the top. And according to angle sum of a triangle being 180, if the 2 angles on these sides are the same, then the third one's going to be the same. So they're similar triangles. So what they can do is they can say, okay, well, let's say that this is 5 and this is 10. The whole length of this is 30. So they might want you to just find the length of this, x. So if I label that on my picture here, I've got 10 is the bottom of this one, 5 is the bottom of this one, 30 is the bottom of this one, and so what's x? So then it's just using the exact same skills we did over here. This one's nice. I've just made it the scale factor same as this one, 1 to 2, which means that 5 times by 2 to get 10, so it must be 15 here. So just be mindful of something like that. Okay, that is all of our rates there. What I suggest you do is go through and practice now all different rates. But hopefully you can see how these 3, they're not 3 different things. They're all just applying, being able to do applications of rates.